everybody. So today I am going to talk to you about um, how to use solution stoichiometry. Just want to see one thing here, make sure that I'm recording with the built-in microphone. Okay, good. I worry a little bit. I didn't know if my voice was recording or not. All right, so let's get to this. So here is solution stoichiometry. Basically, what we're going to do is we're going to apply the idea of molarity to a balanced equation, and we're going to try and figure out, how many moles of product form given the concentrations. Remember, these reactions are occurring in solution. It makes more sense to look at the reactants as if they are solutions rather than grams. We're mostly dealing with volumes of things and moles. First thing I always need to do in a solution stoichiometry problem is I need to balance the equation. So when I go ahead and I do this, I see that I don't have enough NAs or CLs on each side. So if I put a 2 on the left side, on the right side here, then I will have a balanced equation. And so the question is asking me how many grams of barium sulfate form when 50 milliliters of barium chloride with a concentration of 0.5 molar reacts with excess Na2 and so forth. So just like with any other stoichiometry problem, the idea is to try and get the number of moles. So I can use the molarity. 0.5 molar equals X moles divided by 0.05 liters. And then when I do this, I get 0.025 moles. Now, this is of barium chloride. So this is BaCl2. Well, now they want to know about BaSO4, so I look at the mole ratio, just like I do in a normal stoichiometry problem. Every one BaSO4 is formed from every one BaCl2 reacting. The result is 0.025 moles of BaSO4. Now they want the grams, so how many grams form? So now I can take this and I can times it by its gram formula mass. 0.25 moles of barium sulfate. And now I can times it by the gram formula mass, which would be 233 grams for every 1 mole. And this will give me how many grams form. So if we do that in our calculator, we go ahead and we try that out. We will get 0.025 times 233, and I'll get 5.83 grams of barium sulfate forming, 5.83 grams forming. So as you can see, these problems, they're pretty straightforward. How could I make it more difficult? Well, I could give you a limiting reagent problem, where I give you the concentration and the volume of each one, and then ask you to solve. And that one would be more difficult. That one would require you to go through and find the limiting reagent. We can try one of those in class. Okay, another type of math thing that now that you know all the concentrations that you'll be asked to do is dilutions. And so, one of the things that we see is that things come out concentrated. And we buy concentrated products. And so something that we should discuss in class is, what are some good things and bad things about buying a concentrated product? Remember, concentrated means that you have a lot of solute in a relatively small amount of solvent. And we see that this is really something that, companies are trying to do. What are the good points and the bad points? We'll discuss that in class. One of the things that you should know how to do in terms of laboratory techniques is, actually doing a dilution. And the equation for a dilution, when we look at this, is molarity 1 times volume 1 equals molarity 2 times volume 2. And what this is actually showing us is that the moles that you start with and the moles that you end with is the same. The whole idea is that we're just changing the volume. And this is a typical question that you'll see. They give you 5 liters and they give you a molarity. This is normally called the stock solution. So it's the solution that is made in a stock room, and it is the solution that we will use to make a solution that's more dilute. In this case, we want to make a 2 molar solution. This is called our working solution. So how does this look? Well, what we would do is we would take the initial stock, We have 5 liters of it. And we have 6 molar concentration of it. Doesn't matter which order you put them in. And it says that we want to dilute it to 2 molar. So we want to make 2 molar. What volume will that produce? Well, we have 30 equals 2 times the volume. And when we solve for volume, we get 15 liters. So what this means is that I took 5 liters of my stock and I diluted it to a final volume of 15 milliliters for my working solution. So one of the questions that you're asked a lot, which I'll highlight, is how much water was required to do this? Well, if we started at 5 and we ended at 15, we are going to add 10, 15 minus 5, we're going to add 10 liters of water. So in the laboratory, what we'll do is we'll take a stock solution and we'll add enough water to get to our final solution. All right. We'll practice some of these dilution things in class. The last thing that I want to end with for this video is something called colligative properties. The Regents does this, they're into the idea of qualitatively figuring out what a colligative property is. And when I define a colligative property at the top of the page here, it's just a property that depends on how much solute particles I have. We don't really care about their identity as long as we know how many are dissolved. For example, and I give you this example up top here, if I have 1 mole of a salt, NaCl, versus 1 mole of another salt, which is Kf, as long as they dissolve to the same extent and produce the same number of ions, they should have the same effect on the solution's properties. Some of the more common properties that we study of a solution is how its melting point and boiling point changes. And this example up here I talk about, and we might see this if we have a snow day coming up, is why do people pour ice melt, something called rock salt, on their icy driveways? And why do people put salt in their pasta, besides for the flavor that they get? And the idea is that by adding solvent, or adding solute to the solvent, we change the properties of the solvent. So when we add a solute, one of the things that happens is the melting point / freezing point will actually go down, it will decrease. For example, water normally melts at a temperature, pure water melts at a temperature of 0 degrees Celsius. When we add some kind of solute, that freezing point / melting point will actually get lower. How much? Well, the Regents doesn't care, but the honors, they actually do really care, and they want you to know that. And so we'll do an equation on the next couple of slides in the next video that describes that. So when we add any kind of solute to water and it dissolves, it will lower the freezing point. So water normally freezes at about 0 degrees. If it snows out and the roads ice up, the salt trucks will come and they will actually pour or put salt down on the road. That salt will lower the freezing point of the water and it will melt that ice. The other effect that it has, putting salt into water, is it will take the boiling point and it will increase it, make the boiling point higher. And so when we add a solute, the boiling point goes up. Now, to do this, realistically speaking, you would have to add a tremendous amount of salt in order to get boiling pasta water to boil at a higher temperature. That just isn't really, why people do it. They do it for flavor. But we can talk about it theoretically, but you'd have to add a lot of salt to the water to the point that it would not be very tasty if you actually did that. Now, qualitatively speaking, and again, we're going to do the math the next video, but qualitatively speaking, the more ions that you form, the more effect that you get. So for example, if I were to take 1 molar NaCl and dissolve it, that NaCl breaks up into 2 ions in the water. These 2 ions both act to lower the melting point and raise the boiling point. Essentially, you're getting 2 for 1. If I were to put something like 1 molar sugar into water, that doesn't break up. It's covalent. It stays together. And so this you only get 1, not an ion, but 1 particle. And that 1 particle will have less of an effect. You put in 1 molar, you get 1 molar solution. With NaCl, you put in 1 molar, you're actually getting 2 molar. The other thing which is obvious is the concentration. So if you have higher concentration, that will actually equal, and this is molarity, that will actually have more of an effect. And again, you're getting more particles. Remember what a colligative property is telling you? It's saying that it only depends on the amount of solute. The more solute that we add, the more it interferes with the boiling and the freezing, the more of an effect it has. We can try and get a higher concentration by adding more, or we could actually change what solute. We could make the solute a type of salt that will form more ions and have more of an effect. So next time, and you can kind of see it peeking through here on the bottom, we'll go over all of the different types of properties and their math. And that's the honors part of this. All right, thanks so much for watching.